Hey everyone, welcome back to my YouTube channel Tripoli by Prionta. Today we are going to prove Kirchhoff's voltage law in a simple AC circuit using 3 resistors and a sinusoidal source. Let's take a moment to understand what KVL is. Pause here and read it once for a quick revision. This will be our circuit, a function generator to provide 4 volt peak sine wave at 2 kHz, resistors 5 kΩ, 10 kΩ and 15 kΩ all in series, and an oscilloscope to measure voltage across each resistor and across the entire series combination. In this experiment, we will measure total voltage from the generator, individual voltage V1 across 5 kΩ, V2 across 10 kΩ, V3 across 15 kΩ. First of all, let's check the resistor values using a digital multimeter. Let me put the resistor into the breadboard and turn on the DMM. Here are 2 proofs of the DMM. This one is showing 9.83 kΩ, close to 10 kΩ. Now I am placing it on the breadboard. Next, let's measure the remaining 2 resistors one by one using the DMM and place them properly on the breadboard as well. And this is the final theme of the circuit. Now let's turn on the function generator. Here the red probe is the positive one and the black probe is the negative one. Connect the positive and negative probes from the function generator to the positive and negative sides of the circuit to apply AC input. After connecting, now we want to measure V RMS voltage. To calculate it, we divide the peak voltage by √2. Since we are targeting V peak of about 4 volt, the VRMS should be approximately 2.82 volt. To adjust this, connect the DMM across the input terminals of the circuit. Then adjust the amplitude knob of the function generator until the multimeter shows 2.82 volt RMS. And we found 2.82 volt RMS. Next, let's turn on the oscilloscope. Wait a few minutes, it takes some time. Here the channel 1, the black one is the signal probe and the small one is the ground probe. Connect the red probe to the positive terminal of the circuit and the black probe to ground. Now set the Vmax to 4 volt because Vmax is equal to V peak. We can set this by adjusting the amplitude knob. You can see it's now okay. Vmax 4 volt and V peak to peak is 8 volt. You will see 8 division on the vertical scale. If each division is set to 1 volt, that means we are seeing 8 volt peak to peak. You can change the volts per division using the vertical knob and adjust the time period with the horizontal knob. And this will be sine wave, and you can see I am adjusting it by vertical knob and horizontal knob. Currently, if each division is 2 volt and we have 4 vertical division, then 4 into 2 equal to 8 volt peak to peak. Let me adjust again. Listen carefully. First, we will measure across R3, then R2, and finally R1 one by one. We need to interchange the resistors, making the R3 position the base position. Use channel 1 of the oscilloscope to measure the voltage. The positive probe of channel 1 should go to the end of the resistor you are measuring. Do not move the ground probe. It must stay connected to the same reference node. Let's measure R3. You can see the V1 max value. V3 equal to 2 volt, and 1 by 1 let's interchange the resistors R3 to R2 position and R2 to R3 position. See, the value is 1.36 volt. It means VR2 equal to 1.36 volt. Now again I am making the main circuit to avoid mistakes. And now interchange R3 to R1 and R1 to R3 position. Now look at the oscilloscope, and there's a value 720 millivolt. Let me note down VR1 equal to 720 millivolt. Finally, let's add all three values, and we can see it's around 4.08 volt. This confirms Kirchhoff voltage law. The sum of the individual voltage drops equals the total source voltage. If you found this helpful, don't forget to like, subscribe and hit the bell icon for more practical circuit videos. Drop your question in the comments. I read and reply to all of them. Thanks for watching, and I will see you in the next one.